Hi there, this is Richard. I'll be presenting to you my project. The first dataset going through is the Uber dataset. Those are the libraries I'm using for it. First, we load the CSV file into memory. Once you display the data, we can see the number of rows and number of columns. All the data is string type, so one of the data that we need to convert in here is the date and time. That's what I'm doing in here. We have all the comments, you can go through it. Once you display the data again, you can see it has changed. Now it's a timestamp format. You can see the difference between them. You can check that as well. Once you check that, you get, that's the output you get. See for the first index, which is the index 0, it's a timestamp format now. While working with the data, I saw we would need to create a couple of functions in order to get all the analysis I wanted. So they are for the day of the month. Another one to get the weekday, hour, the number of rows. Once you display the data again, you can see those columns have been created. And the first analysis I carried out was to check the frequency of the rides by the day of the month. As you can see in the graph, Sundays and Mondays are the days with the less rides happening. So that's the kind of information Uber or the employees themselves, they can, if they have knowledge that they know, like, okay, like what are the days to make the most of the money? What are the days that they could take off, for example, or they could have less people working at that day. The next one is the same as above. The difference here is just like sorting the data. You know, it's from the days with the least rides to the days with the most of the rides. You can see here on the axis labels like the date of the month. That's the data set for August. So the next analysis is the frequency of the rides by the hour of the day. So here you can see like most of the rides are happening between 4 p.m. and 10 p.m. That's another information like Uber or the employees they can use, and they can say, look, the best time to be working is between 4 and 10. So that's when we make most of the money. Some of the other hours we have been doing not so great, so, you know, can allocate more staff, less staff to different times of the day. The next one is a cross analysis. We're checking the hour against the day of the week. This is what we have, the weekday, the hour. So you can see that the cells in darker, they have the larger degree. So it's the same information. You want to make money, when should you allocate those stuff, what's the day, what's the time. The next one, just checking the latitude and longitude with the range that had most of the rides for the location happening. We had to use twin in order to plot those together because of tape of the different date where we have the latitude and the longitude, the different numbers. So this is what we get. Here we are just checking the variation of latitude in the data. This is a scatter plot, so you can see all the variation on the data. Most concentrated in here. Say the next one is the same, but now for longitude, so you can see here the concentration. The next one was like probably like the coolest one. It's a spatial visualization. I'm using volume for that. So in here I am using just this amount of rows because my computer was not able to handle the whole data set for this particular analysis. We are setting the range, location, latitude, the longitude, giving a zoom to it, and you can see that the most of the rides, they are happening here in Manhattan. This is New York, so you can even zoom out. It's a little bit slow, but you can see that's where most is focused. You have a lot going on in here as well. But once you start zooming, you see that's the biggest one. The next one, it's in cluster with, I am using marker cluster. It's part of volume as well. So in here, you get this really cool map, very detailed. You can get the radius of each cluster. Once you click on each of the clusters, you can see where most of it is happening. Again, it's the same as kind of above, so you can see it's Manhattan, but you have a much better, nicer visualization of it all. It uses the OpenStreetMap, So that was a very cool type of visualization. The next analysis is related to, the beach weather stations. Those are the libraries loading again the file to the memory. So we start here, get some statistical insights of the columns. You can see we get here the count, the mean, standard deviation, the minimum, the maximum, the percentages for each of those columns. Once you display the whole data, you can see all the columns we have with the data, the number of rows, the columns. Then here we can, to do the next analysis, you can get the unique station names for each. You can see we have 3 of them. Then when you go to calculate the mean for the stations, you can see here for Foster weather station, you have some NEAs on the data. So what we need to do is fill those NEAs with some zeros. We have all the comments in here. And for a better visualization, use background gradient, which gives us this graph here. And you can see where it's darker, it means the higher degree, whereas the light ones, they have less degree on it. Those are the zeros you filled in. The next analysis is we are trying to find the trend for humidity. As you can see here on the graph, actually no trend was found as the data varies too much. But we can get a conclusion that, there is no trend for this, which is also something helpful. Then we start with some correlation of the data. Again, you are using background gradient. It's good for visualization, so it's cool. Here you can see the darker ones, they have a higher degree, whereas the lighter ones, they have less. So for example, we can see that the correlation between interval rain with rain intensity, precipitation time, then you can see, let's say, rain intensity and wind direction, for example, it has much less, like it's some of the lowest. Again, you'd have here, this one here have very high degree, the wet bulb temperature with air temperature. The next one is, we are analyzing the wind speed frequency. So you can see the frequency of the wind. You can get some insight of it. We can conclude that at some particular time or day, we can perhaps have advise people that perhaps they should stay at home or they should protect themselves more, because at some certain points, the wind tends to get too velocity. So, they need to protect themselves. The next one, we are using this formula here. We are analyzing the wet bulb temperature versus the air temperature. We get this graph here, and you can see the steepness of this, it's increasing. So for the next one here, we are using the k-fold cross validation to validate the model of the data, as it compares and select the model for the predictive modeling problem. So it helps us to estimate like the skew of the model. You can see here on the results we got, like this is the score we have, and we have predicted that the air temperature value is this one in here for the wet bulb temperature of 23 for my most accurate model. That's pretty much it for the analysis. Thank you very much.